Hello dear students, in the previous class we have already studied about what is an electric charge and its various properties. And among the different properties of electric charge, you all already know that like charges repel each other and unlike charges attract each other. So from today we are going to start Coulomb's law. What is a Coulomb's law? Coulomb's law basically gives us the magnitude of the force with which the like charges repel or the unlike charges attract. It is commonly known as the electrostatic force acting between the two charges. So in order to facilitate you all to make the notes, I noted down the important points which are related with Coulomb's law. So what is Coulomb's law? Coulomb's law, the first point which we are going to discuss is that it gives us the magnitude of the electrostatic force which acts between the two charges. Now for example, let us suppose that we have got two charges Q1 and Q2 which are placed at a certain distance apart. So, and the polarity of the charge or the nature of the charge is same. You can see this is Q1 is positive and Q2 is also positive. So, as we know, the like charges repel each other. So, Q1 will apply force of repulsion on Q2, which is marked as F21, and we are going to read it as force acting on 2 due to 1. This is force acting on 2. 2 means the second charge due to 1. Alright. So F21 stands for force acting on 2 due to 1, whereas F12 stands for force acting on 1 due to 2. And since the two charges are of same type, same nature, both are positive in this case, so the direction of the force, as you can see, is away from the charge, repulsion. Q1 is repelling Q2 away from itself, and in a similar way Q2 is repelling Q1 away from itself. Likewise, if we have two charges of opposite nature, Q1, Q2, and Q2 is negative in this case. So now the charges are of different type, different nature, different polarity. So now we are going to attract each other. So the direction of F21, that is force acting on 2 due to 1, is towards Q1, and the direction of F12, that is force acting on the first charge due to the second charge, is towards Q2. Alright. So, like charges repel each other, unlike charges attract each other. This you people already know. Okay. Now, the next point is about electrostatic force is that electrostatic force forms action and reaction pair. So you have already studied in Newton's third law in class 11 that when force of equal magnitude acts on two different bodies, the important point is that the force of equal magnitude acts on two different bodies in opposite direction, then they form action and reaction pair. So in a similar way, the electrostatic force F21 and F12 both are acting in opposite direction. This is towards right, this is towards left, and the magnitude of both the forces is also same. So you can write this as F12 is equal to F21, right? Since we are talking about the magnitude, so we are going to put a modulus sign. Alright. If I could not put the modular sign, then in that case I have to put a negative sign. Please make a note of this. F12 is equal to F21, the minus sign. Because here we are only considering the magnitude of the forces, the electrostatic force. Here we are also considering the direction of the force because we have not put the modular sign. Alright. So electrostatic force forms action and reaction pair. I hope you all have understood this. Action and reaction pair because there are two conditions to identify whether a group of force or a pair of force form action or reaction pair or not. The first thing is that the magnitude of the forces should be same. So the magnitude of the forces in this case is same, F12 and F21. That is force applied by 1 on 2, F21, and force applied by the second charge on the first charge, that is F12. Both are equal in magnitude and their directions is opposite. Whether you consider the case of like charges or you consider the case of unlike charges, in both the cases the 2 points or the 2 properties relating with Newton's third law are getting satisfied. So therefore we can conclude that the electrostatic force forms action and reaction pair. I hope you all must have understood this second point as well. Now there is another important point. The electrostatic force acts along the line joining the two charges. Alright. So acts along the line joining the two charges means if I join these two charges, in fact, so as you can see the direction of the force, it is not acting perpendicular to the charge. It is not acting perpendicular to the charge, not acting perpendicular, likewise not acting perpendicular. It acts along the line joining the two charges. It is along the line joining the two charges in both the cases. When the charges are of same nature or when the charges are of opposite nature. Clear? Now, before we move on to, I hope the third point is also clear to you all. Before we move on to the fourth point, let us see the magnitude of the force. Now, this basically is Coulomb's law. So, Coulomb's gave us the magnitude of the electrostatic force. Alright? He gave us the magnitude of the electrostatic force. So F12 and F21, alright, F12 and F21, both forces are equal according to the second point, and they are forming action and reaction pair. So what is the magnitude of F12 and F21? The magnitude of the forces given by 1 upon 4 pi, the symbol is known as epsilon, and medium. I'll explain this. What does it mean? Q1 Q2 by R square. So this is 1 upon 4 pi epsilon of the medium Q1 Q2 by R square. Now what is epsilon? Epsilon is permittivity of the medium. Please note it down. Epsilon is permittivity of the medium. Note down the definition of permittivity. Permittivity is a characteristic of electrical property of a medium. Permittivity is a characteristic of electrical property of a medium. Alright? In the next class we will see this in detail. So for this class we can note down that permittivity is an electrical property of a medium. And as you can see its relation with the force, it is inversely proportional to the force. F is 1 upon 4 pi epsilon, so it is inversely proportional to the force. So larger the value of permittivity of the medium, smaller will be the magnitude of electrostatic force in that particular medium, because both are inversely proportional to each other. So now we can move on to the fourth point. The electrostatic force depends on the medium in which the charges are placed. Another very important point. Okay. Now for free space, permittivity is known as epsilon. The symbol is epsilon, and we put a knot here to denote free space. So this knot here denotes free space. Epsilon naught is 8. The magnitude of epsilon naught is 8.85 into 10 to the power minus 12, and obviously you can derive unit for this, which is Coulomb square upon Newton meter square. Alright. Now how is this electrostatic force different from gravitational force? Because both electrostatic force and gravitational force are non-contact forces. We have already studied this in class 10 about contact force and non-contact force. As you can see, the charges are not joined or not connected to each other, but still the electrostatic force acts on it. Similarly, if I replace Q1, Q2 by M1, M2, the mass of these two charges, then there will be a gravitational force acting between the two masses. So a gravitational force is always attractive in nature, whereas electrostatic force is attractive when the charges are of opposite type, and it can be repulsive when the charges are of same type or same nature, in fact having same polarity, plus or it can be minus. Another very important point that you should make a note of is that gravitational force does not depend upon the medium in which the masses are kept. This is another very important point. You know that the value of gravitational force acting between two masses is given by Gm1 m2 upon r square. R in both the forces is same. R is obviously the distance between the two charges, and if you are considering mass in case of gravitational force, then R is the distance between the two masses. So gravitational force is independent of the medium, because this is G, which is universal gravitational constant. No matter where these two masses are kept, the magnitude of gravitational force will remain constant. But it is not the case when we come to electrostatic force. Electrostatic force depends on the medium in which the charges are kept. Means if these two charges are placed inside water, then the magnitude of electrostatic force acting on these two charges will be different as compared to if they are placed in free space or vacuum. But the value of the gravitational force will remain constant whether the masses are kept in free space or they are placed in any other medium. Alright, so that's all for Coulomb's law. In the next class, we shall see what is electric field, and I will also discuss in detail a little bit about permittivity of the medium and relative permittivity. Thank you.